Okay, let's start. First, I would like to introduce myself. Myself, Faisal Mohammed. I'm currently a research associate in the Department of Computer Science and Engineering, and the current ongoing research is related to the artificial intelligence enabled next generation energy management system. And I will give you some of my background. I did my Masters of Engineering from this university as well, and my bachelor's I completed from University of Kashmir in the same major, that's computer science and engineering. And furthermore, my research interests are deep learning, machine learning, data analytics, time series prediction, deep reinforcement learning especially, and partly our lab where I'm now currently working. We have worked on many projects, and it was the elastic optical networks, then later on it was electric vehicles. Now it's the next generation energy management systems in the smart grids. Okay, let's move ahead. Today I'm going to present one of the review paper which was published in IEEE Access last year. The title of the paper is A Review on the Challenge of Autonomous Mobile Robot and Sensor Fusion Methods. And let's introduce about this paper. As we know, the autonomous mobile robots are deployed in most of the sectors. That means the mobile robot is a system that operates in unpredictable and partially unknown environment. That means it can have any kind of environment which was not known to him, which is not fed to it, or we can say on which it is not trained before. So it has to operate in certain environment which can be new to it, and it has to perform and give the best of the results. And autonomous mobile robots has little or no human intervention for its movement, and it is designed in such a way to follow a predefined path, be it in an indoor or outdoor environment. For indoor navigation, for example, the mobile robot is based on floor planning, floor plan, sonar sensing, and inertial measurement units, etc. And some of the tasks which are considered or which are focused in this paper are or which the autonomous mobile robots have to take care are the locomotion, that's the movement, navigation, that means from the start of the origin to the destination, the path it has to traverse, and the perception, how to deal with the environment. And some of the applications further described here are the surveillance. They are used extensively in the surveillances nowadays, and there are other services like the cleaning services, research and education, customer support, and manufacturing industries. Some of the related works discussed in this paper is the locomotion. For example, in case of locomotion, we should know what is the locomotion that the robot has to perform. That means it depends on the services that are to be rendered. Therefore, the mobile robot can be designed to walk, run, jump, or fly. And to develop this locomotion system, we need to deal with the different types of the terrains. It can be uneven, level ground, stair up, stair down, and non-traversable terrains like that. Therefore, installation of the active wheels usually adds up to the whole weight of the vehicle, which is already hefty enough, limiting the versatility of the leg mechanism. There are some problems which we are dealing with in case of the locomotion of the robots. And the second thing is the perception. What is the perception? Is an imperative aspect in the mobile robot study. If a mobile robot is unable to observe its environment correctly and efficiently to perform the tasks such as estimating the position of an object accurately may be an issue. And navigation is the third important aspect of this research. That is the most, what is the navigation? The most important aspect of in the design of the mobile robot is navigation abilities. What means the navigation? That means the to navigate the robot from the destination, from the origin to the destination, either in an uncontrolled environment or the controlled, or we can say the recognized environment. And some of the target goals of the current ongoing research which are discussed in this paper are as like this. This paper describes the challenge of the autonomous mobile robots and gives some indication about the sensors and techniques in the mobile robot positioning, and it also describes which is the main function, or we can say that it is needed much more in the robots. That's the object recognition and the feature matching. And it also gives some indication about the sensor fusion techniques and classification of the sensor fusion algorithms and their importance. And finally provides some future research areas which we need to deal with. First, let's go for the challenge of the autonomous mobile robots. The challenge of autonomous mobile robots, as we know, these challenges have enabled more researchers to develop more interest in the recent time, and they have been divided or categorized into three classes. The first one is the navigation, the path planning, and the second one is the localization, and the third one is the obstacle avoidance. First, let's go for the navigation and the path planning. What is that? That means it deals with the distances, scales, and the obstacles. And we can say the landmarks, or for example, to accurately determine the position and the orientation of the mobile robot, we need to design it in such a way that it can navigate and decide the path in an accurate and a precise way. And three main three main techniques for representing the environment which are given as: the first one is a geometric, the first one is a geometric, the second one is a topological, the third one is a semantic. What is the geometric? Geometric deals with the curves and the lines and the points, and actually the robots should have the sensors and the actuators with what they sense from the external environment. Accordingly, they give the response using the actuators. And the geometric shapes and the figures, they have to deal with how to move or how to traverse their path. The second one is the topological. What is the topological aspect? That means this is considered by defining the reference elements of the environment according to the distinct relation between them. For example, topological representation of the environment uses the graphs to model the environment, and it is used in large navigation tasks. And the third one is the semantic. What is the semantic aspect of the navigation and the path planning? That means the current development in the robot is to elevate from the representation models that are closest to the robot's hardware, such as geometric models, to those models closer to the human reasoning. And the robots that are provided with the semantic models of the environments where they operate have a larger decision autonomy and become more robust and more efficient. And semantic information constitutes the better solution for the interaction with the humans actually. And further, in the general, there are two types of environments, as we know: the static environment or the dynamic environment for the path planning. For example, like the environment which is static, which the robot already knows, and the dynamic environment changes with the time, like that. And further, we can divide the dynamic environment into two classes, that is the global or the local environment. The global usually, which is the known environment, and the local is the unknown environment. And for to deal with these tasks, we have a lot of algorithms. To deal with these tasks, navigation and the path planning, we have a lot of algorithms like the harmonious search algorithm, evolution algorithm, path algorithm, etc. And the second challenge of the autonomous robot is the localization. What is the localization? It is a fundamental issue encountered in the mobile robot, which requires attention. And the challenging part of the localization is estimating the robot position and the orientation, which we get by the information from the sensors or other systems. And the localization is further divided into two categories: the techniques which deal with this localization. One is the relative localization techniques, the other one is the absolute localization techniques. And the relative localization technique gives or estimates the position and the orientation of the mobile robot by integrating the information produced by diverse sensors. And these can be the inertial sensors, like that, and the relative positioning alone can be used only for the short period of the time. And absolute localization, this method actually permits the mobile robots to search its location directly from the mobile system environment. For example, we use a GPS kind of thing to do this kind of localization. And the third challenge of the autonomous mobile robot is the obstacle avoidance. That means it will face many kind of obstacles uh, during the traversal of the path. So we need to design some algorithms which are collision-free algorithms, like to deal with the obstacles. Let's move ahead. And the second target of this research is the sensors and the techniques in the mobile robot positioning. And we can see there are many kind of sensors. The initial sensors, which are further divided into the three types of categories: the accelerometer, the gyroscope, and the magnetometer. And we can say that the accelerometer, we describe a little bit about the inertial sensors. What are the inertial sensors? Inertial based sensor methods, also known as inertial measurement units, which is, as we described, that they are the combination of the accelerometers, gyroscopes, and magnetometers. They rely on the measurement of the acceleration and heading and angular rates, etc. These are the inertial sensors which are embedded in the robots. The accelerometer, for example, gives the linear acceleration, velocity, like that, how the robot is moving, at what speed, like that. The gyroscope is the second one, which gives angular velocity, or the revolutions per second of the robot. And the third one is the magnetometer, which is another sensor used to calculate the heading angle by sensing the Earth's magnetic field. And the second one is the monocular vision positioning system. This is the second technique. And what is the monocular vision positioning? It uses a single camera, ocular vision. When we listen this kind of words, we think about the camera or the image, like that. And here, the monocular vision positioning, it uses a single camera to determine the pose estimation of the mobile device and static objects. We can say the environment. And nowadays, there you can find binocular visions as well, which has two cameras to estimate the location of the mobile robot. The monocular vision positioning system can be used to estimate the 3D camera from the 2D image plane. And the third technique in mobile robot positioning is the landmarks. Landmark actually is a feature information recognized through the robot's sensors perception. For autonomous robot, how to identify landmarks quickly and accurately plays an important role in the localization as well as in navigation. So usually we use, in case of landmarks, we use two kinds of landmarks. Where one is the marked landmarks, the second one is the uh, marker based landmarks. The other one is the markerless landmarks. Marker based landmarks are also known as the artificial landmarks, which are designed by the researcher, or we can say which are designed artificially, and natural landmarks which are already present there, and we have to detect those landmarks using the object detection algorithm like that. And for that we use different kind of algorithms, as I told, like SIFT is one of the algorithms, scale invariance feature transform, which maps the pixels from the one image which is fed, which is already known to the robot, and maps it to the second image, which is a similar image but of the different environment having the same kind of objects. So this kind of algorithm actually uh, maps the pixels from one image to the another image. And let's move ahead to the another target of this research paper is the object recognition and the feature matching. And in this section, actually, the object recognition and feature matching algorithms have been discussed a lot. And some of the methods like are oriented, fast and rotated method, binary, robust invariance, scalable key points, difference of Gaussian, and these kind of methods have been discussed in this paper. I'm using some references. For the detail, we can refer to this paper, refer to those references from this paper. And object detection and recognition can be done using the computer vision, whereby an object will be detected in an image or the video sequence. And object detection can be divided into three aspects. One is appearance based, the second one is color based, and third one is a feature based. And for this we have some algorithms. One is a speeded up robust features, the second one is a random sample consensus. What is the first one is also known as the SURF algorithm. It was introduced in the reference 76 given in this paper, and actually it is we can say the updated version, or we can say it's a betterment of the SIFT algorithm. SIFT algorithm was a previous algorithm, but it had some limitations, so they proposed, the authors in the reference 76, they proposed the SURF algorithm, which outperform the SIFT with respect to the repeatability, that means reliability of the detector for finding the same physical interest points under different viewing conditions. And the second algorithm is the random sample consensus, that's called the RANSEC algorithm. It's actually the iterative method to estimate the parameters of a mathematical model from the set of observed data which contains the outliers. And the concept for detection and identifying the object in the scene is the same. We follow certain steps, like we give the input training image, we convert the image to the grayscale, and we just get rid of the distortions present in the image, and then use the SURF algorithm to detect the feature points, check the image pixels, extract the feature descriptors, and use the algorithm to match query, and like that, which is described in this paper as well. And let's move ahead about discuss something about the sensor fusion techniques, because this paper is titled as a review on the challenge of autonomous mobile robots and the sensor fusion method. What is the importance of the sensor fusion techniques in the mobile robots? And sensor fusion techniques actually is a kind of data fusion, which is we can say the multi-level procedure dealing with the association, correlation, and the integration of the data information from the single and the multiple sources or the sensors to attain some hybrid position, or we can say estimate the position of the mobile robot. And there are many definitions which have been given for the data fusion. What is the data fusion? What's the sensor fusion? Actually, one of the definition is the data fusion techniques. Data fusion techniques combine the data from the multiple sensors and relay the information from the associated database to achieve the improved accuracy and more specific inferences that could be achieved by the use of a single sensor alone. And the advantage of the sensor fusion techniques is to reduce the uncertainty, increase the accuracy, and reduce the cost as well. And the three fundamental ways of combining the sensor data are the competitive way, complementary way, and the cooperative way. Competitive fusion combination increases the robustness of the perception, while the cooperative and the complementary fusion provide the extended and more complete views. The methods particularly used the fusion level is subject to availability of the components. And let's move ahead. There we classify the sensor fusion algorithms into two categories. One is the state estimation method, the second one is the decision fusion method. The state estimation method actually estimates the state that is in the actually estimates the state in which the robot was and the next state where it is going to be. By collecting the data, state estimation phase is a common step in the data fusion algorithms, since the targets of observation could come from the different sensors or the sources. And final goal is to acquire the global target state from the observation. And the state estimation methods are further have the two common algorithms like the Kalman filter and the particle filter algorithms. And here is given the list of the algorithms which are divided into the two categories. They are classified into two categories. One is the state estimation category, and the second was the decision fusion category. And to understand these kind of algorithms, we need to refer these papers, and so that we can get some idea. Similarly, the decision fusion based method also is divided into two categories, approach. One is a Bayesian approach, the other is a Dempster-Shafer approach. And finally, what is the importance of sensor fusion algorithms? First is a reduction in uncertainty. Data provided by the sensors is sometimes subjected to some level of uncertainty and discrepancy, and the multi-sensor data fusion techniques reduce the uncertainty by combining the data from the numerous sources. It is therefore imperative to compensate using the other sensors by fusing their data together using the data fusion algorithm. And the second one is increase in accuracy and reliability. Integration of the multiple sensors sources will enable the system to provide inherent information even in the case of the partial failure. The third one is the extended spatial and the temporal coverage. That means now we can, if we use more sensors and fuse out their data, so we can cover more area and for a longer amount of the time. And the other two are the improved resolution. We can get the improved resolution of the target image. The resolution resulting value multiple independent measurements fused together is better than the singular sensor measurement, and the final one is a reduced system complexity. The system complexity will be reduced. And the future research areas discussed in this paper are as follows. That means to continue to research on the new systems and new methods with the aim to unravel the specific sensor fusion problems for robot navigation and localization. Several directions seem to call for further investigation, despite other related works carried out in literature, like we have the 3D indoor environmental modeling, landmarks, feature extraction, distinct object, topological and modeling, localization, perception planning, and world modeling. And the conclusions discussed in this paper are as follows. In this paper, the authors have been able to provide the background and identify the challenge of the autonomous mobile robots. These problems, such as navigation and localization, are what limit actually the performance of the robot. So there are some techniques which have been discussed in this paper, how to tackle those challenges. And the objective is actually what's the objective of the mobile autonomous mobile robots is to integrate multiple data sources with the sensor fusion technology. I mean to say, the objective is to integrate the multiple data sources to produce more consistent, accurate, and useful information for the mobile robots, so that they can take the decision in the better way. And further, the strengths and the weaknesses of these approaches are also presented, exploring the conceptualization and benefits as well as the existing methodologies. Sensors are categorized into how to relate to one another, and this is called the sensor configuration. And the mostly used sensor configuration for the autonomous mobile robot is complementary one. As we discussed before, the sensor fusion techniques, there are complementary, competitive, and cooperative. So the complementary one are the better than others. And finally, this paper also highlighted some of the research areas that can be investigated for the further work. Thank you for your kind attention and listening to this. Thank you so much.